Algebra 2 students, this is Mrs. Tran-Bloom. I am your Algebra 2 teacher for this year. I'm excited to introduce you guys to the very first section here of your notes packet. So please have this printed out, bring it to our class every day. So each day that I see you, I will be stamping your notes, okay? Your play pause it notes will be 5 points. If it's late, it'll be half credit. And you have to take notes down on this packet or on your line paper. Now, in the case that you cannot print at home, please come and see me at tutorial. Maybe I can go get you a packet or print you a packet. Okay, again, if you cannot print at home, please come and see me during tutorial. But you do have to take notes down on line paper or graph paper or on this packet. This packet normally will last us about a month. Okay guys, here we go. Let's start with 1.1, evaluating functions and solutions of functions. Okay, functions are typically named in mathematics with lowercase letters like F or G or H or J or whatever lowercase letter we use. Suppose a function is named F. Another symbol that means the output of the function is f of x. So output, it's f of x. In fact, the symbols y and f of x will be used interchangeably. Both stand for the output of function f. If one desires to know the output of a function f when the input of the function is 4, then the idea could be communicated in several different ways that all mean the same thing. So let me talk to you guys about the input part. Input, students, is typically mean the x value. Output is y, or because we are studying functions, it will be f of x or g of x or j of x or h of x or whatever variable we're using, okay? So again, so this is interpreting. It says here, let me read this last sentence one more time. If one desires to know the output of a function f when the input, which is x, of a function is 4, then the idea could be communicated in several different ways that all mean the same thing. But all of this means the same thing. What is the output of function f if the input is 4? Or aka, what is the y value of function f if the x value is 4? What is f of 4? So as you can see, the first two ways are longer to communicate. In mathematics, if we say what is f of 4, it's just a lot quicker. Examples 1 to 4. Suppose that the table of values to the right is a representation of function f. What is f of 4? So as you guys know, this is your x value. We're looking for the y value when x is 4. Well, here are all the x's, right? But we want to look for y when x is 4. So that means it's 51. So f of 4 equals 51. What is f of 1? So we want to go look for, remember this right here is x. So we're going to look at when x is 1, y is 7. So f of 1 equals 7. Okay. So this is also can be written as 1, 7. That's an order pair. This could also be written 4, 51. That's an order pair. And again, this is the x value. We're looking for y when x is 2. So this right here will give us an answer. When x is 2, y is going to be 12. So f of 2 equals 12. That could be written as a 2, 12. Okay, so that's an answer, that's an answer, and that's the answer for 3. If one desires to know the input of a function f when the output of the function is 10, okay, remember input is x, output is y. So we now know the y value is 10. Then the idea could be communicated in several different ways as well that all mean the same thing. So here we go. What is the input, which is again x, okay, of the function f if the output is 10? Another way is, what is the x value of function f if the y value is 10? What is x if f of x is 10? As you can see, the first two ways are a bit longer to say or communicate. In mathematics, usually we use this third way right here, which let's answer example 4. What is x if f of x equals 10? So we're looking for x when y is known as 10. Well, we can go back to our chart again. This is when y is 10. So when y is 10, x is going to be 3. Sometimes we write this as an order pair, 3, 10. So the final answer here is x equals to 3. Examples 5 to 8. Suppose 1 is given the following functions. This one, remember, we have 2 functions this time. Your k of x equals the absolute value of x plus 6, and w of x equals 2x squared plus 3x plus 1. Find k of 4. So students, remember, find k of 4 meaning that your x value is 4. We're looking for the y value. So k of 4 is, well, we have 2 functions. One is called k and one is called w. Obviously, we are going to use the k function since we're looking for k of 4. Well, the k function is an absolute value, and there's a blank plus 6, so that's what the x is, right? So that's where we're going to plug in your x value. Your x value in this problem happens to be 4. So 4 plus 6 is 10. Absolute value of 10. Oops, 10. Whoa, that looks... Absolute value of 10 is still going to be 10. So final answer is 10. Number 6, find w of 3. So this is going to be your x value. Again, we're going to look at the w equation. So w of 3 equals, and this one has 2x squared plus 3x plus 1. So we see the first x, I'm going to leave it blank for now, but that x is getting squared. Then we see a second x, I'm going to leave those blanks and then fill in whatever x I'm given. Then we drop down the 1. Well, each time we see an x, we are going to plug in this right here, right? Because that's w of 3, so that's your x value. So we're going to go 3 and 3. So 3 squared is going to be 9. So 2 times 9 plus 9 plus 1. So that's going to give us 18 plus 10. So our final answer, students, is going to be 28. Whoa, that looks like a funky box. Okay, all right, guys. So find w of a negative 0.5. So obviously we have to go to the w function, which is this one right here. So w of a negative 0.5 is 2 times x squared plus 3 times x plus 1. So I want to enter in a negative 0.5 in both locations of x, okay? Now, a negative number, when you square it, that would be a positive number, positive 0.25. 3 times a negative 0.5 is going to give us a negative 1.5 plus 1. 2 times 0.25 is going to give us 0.5. And then negative 1.5 plus 1 is going to be negative 0.5. Positive 0.5, take away 0.5, that would end up in 0. So that one would be 0. Now this one says k of negative 9. So we are going to do the k function here. So k of negative 9, which is an absolute value. Plug in negative 9 each time you see an x. Negative 9 plus 6 is now going to be a negative 3 inside of the absolute value. And we have to simplify that. So it's going to be a positive 3. So final answer. A solution, okay, it's a value or sometimes values that can be put in place of a variable such as x that makes an equation true. For example, the solution of the equation 3x plus, x plus 3 equals 7. It's the x is 4 because we put 4 in for x, then the equation would be 7 equals 7, which makes it true. When an equation has more than one variable, such as in this case, as you can see, y equals x plus 3, we have a y and an x. A solution also requires more than one number. In this case, x is going to have to be 4 and y is going to be 7. Because we put 4 in for x and 7 in for y, the equation would be true, hence 7 equals 7. We generally write that solution as an order pair. So if we have x equals 4, y equals 7, we can write it as an order pair. Notice that the point 4 comma 7 is not only, okay, not only the solution to the equation. The point 2 comma 5 would also be a solution since it would make the statement true or the equation true. Can you name a third solution? Okay, so to find other solutions, we can typically let x be anything we want. Well, 4 is already used, so we don't want to use 4. 2 is already used, so we want to use another x number that's not what we already know. So no, easiest one, students, is 0 or 1 or -1, or in this case 3 is not used. We can use 3. Even 10 is not bad, right? So if we plug in 0 for x, we can go, okay, y equals 0 plus 3, which is 3. So another solution could be 0 comma 3. And again, you can have infinitely many solutions. What does this look like graphically? So we want to graph out this line. This is a line of y equals x plus 3. So y equals x plus 3. Your y-intercept is at 3. So I'm going to go up and make a dot at 3. Your slope is going to be 1 over 1. So I'm going to go up over 1, up 1 over 1, just like this. I can also go down. Remember, the more dots you make, then the straighter your line's going to be. And I'm going to use my ruler and connect all my dots. Make sure it's okay. And arrows on the end. So there is the line. Now, what does this look like graphically? So all of the solution, I'm going to start with the first one, okay? The first solution we have is 4 comma 7. So 2, 4, this is your first dot. So all of your solutions, students, should be on this line, okay? If it's not on the line, then it's not a solution. 2 comma 5, this is your solution. Then we came up with one on our own, 0 comma 3. Okay, so as you can see, a solution must be true, and to be true, it has to be on that graph. How many solutions are there to this equation? As you can see, this line can have infinitely many dots. So there could be many, many different solutions. So there will be infinitely many. Okay, so that means there's just too many for us to count. Okay, guys, let's go to the next set of examples. 13 to 15 sets. Verify mathematically that each point is a solution to the given function. Then find one additional point that is a solution. So what we are asking you to do is make sure that we know that this point, and this point belongs to those equations. And then not only that you have to say yes or no, you have to come up with another one on your own, okay? Well, to verify, it's quite easy. We plug in x and y. So x is going to be 5, y is -3. So -3 equals 5 squared minus 4 times 5 minus 8. Now we want to make sure it's true. If it's true, then it is a solution. But if it's not true, then it's not a solution. That's as easy as it is, right? So next we want to go, okay, well 5 squared is what? 25. Minus 20 minus 8. -3 equals 25, take away 20 is 5 minus 8. -3 equals -3. Check. So this is, okay, so that is a solution. 5 comma -3 is a solution. Now you have to come up with one on your own. So you can, guys, to come up with one on your own, you can pick an x value, anything you want except 5. So I'm going to go and pick 1, okay? So y equals 1 squared minus 4 times 1 minus 8. So 1 squared is 1 minus 4 minus 8. And that's going to be -3 minus 8, which is going to be -11. So my one other answer is this. Okay. Okay, next. Let's see if 3 comma 0 it's a solution for 4x minus 7 equals 12. So this is x, this is y. So 4, x is 3, minus 7, y is 0 equals 12. This is 12. 7 times 0 is 0. So 12 equals 12, check. So don't forget to write yes. And then I want you to come up with another answer. Now this next one, I'm going to use, well, I want to use x equals to 0 because that's not 3, so I can use that, okay? So 4 times 0 minus 7 times y equals 12. Well, 0 times 4 is 0, so negative 7y equals 12. Divide both sides by negative 7. Y is going to be negative 12 over 7. You can leave that as an improper, or you can even write it in mixed numbers. So, oops, not negative 1 and 5 over 7. Either way, I will accept as long as in the simplest form. So my one more answer could be 0 and negative 1 and 5 over 7. Okay, guys. 15. Let's see if 1 comma 9 is the answer for y equals 2 times the quantity of x minus 1 to the third power plus 9. So x and y. So y is 9 and x is 1. 1 minus 1 to the third plus 9. Remember, PEMDAS says to do the parentheses first. So 1 minus 1, 0. 0 to the third is going to be 0. 2 times 0 is going to be 0. And 0 plus 9 is going to be 9. So 9 equals 9. So that's a yes. Now, this last one, I want you to come up with a point on your own. Remember, to find another additional, meaning that x value has to be different from what we already have. So you can pick anything you want, all right? So since I can't use 1, we can use, I already used 0, and technically you can use 0 again for example 15 because they're not related. So let's do 0. Why not? Because it's easy. So y equals 2 times 0 minus 1 to the third plus 9. Y equals 2 times negative 1 to the third plus 9. Negative 1 to the third, students, is going to be negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 9, that's going to give me a positive 7. So another answer is 0, comma, positive 7. And no, that's not the only additional. You can have so many more. All right, let's go to example 16. Looks like this is our last one. Here we go. Which of the following points are solutions to the function f of x equals the quantity of x plus 4 times the quantity of x minus 8? And we're doing the same thing, okay? We are going to plug in x and y and then see if it's true. So x is 8, y is going to be 0. So f of 8 equals f of 8 and above 0. F of 8, okay. X plus 4, so that's 8 plus 4 times 8 minus 8. Our whole goal, student, is to see if it's going to come out to be 0, okay? So this is going to be 12, 8 minus 8, 0, and that's going to be 0. 0 matches with 0, so yes, this is definitely a solution. All right. Let's do this one. And again, this is x and y. We want to plug in x to see if y comes out to be 0. So f of 4 equals 4 plus 4 times 4 minus 8. Well, 4 plus 4 is 8. 4 minus 8 is going to be negative 4. 8 times negative 4, students, negative 32. And negative 32 does not look like it's going to be 0. So this is not a solution to our function. Okay, same thing. Here's x, here's y. Our job is to make sure when we plug in 0, y comes out to be 30. So f of 0 equals 0 plus 4 times 0 minus 8. 0 plus 4 is 4. 0 minus 8 is minus 8. 4 times negative 8 is negative 32. Negative 32, students, is not identical to positive 30, so this is a no. Okay. All right. Now let's do D and E, and we're almost home. Again, this is x and this is y. So f of negative 1 equals negative 1 plus 4 and times, this is going to be negative 1 minus 8. I'm trying to not invade the space for e. All right, negative 1 plus 4, that's going to be positive 3. And negative 1 minus 8, that's going to be negative 9. 3 times negative 9, students, is going to be negative 27. And that is the same. So that one is a yes. Okay, so negative 1 comma negative 27 is definitely a solution. All right, last one. I want you to work it out and let me know, okay? So this is on your own. Show all your work. I'll see you guys in class for SAM.